All right, so Charlene makes $10 per hour babysitting and $5 an hour gardening. She wants to make at least $80 a week, but can work no more than 12 hours a week. Write and graph a system of linear inequalities that describes the situation and lists two possible combinations, linear combinations specifically. So, well, I need to define my variables. We want to be very specific about how we define our variables because I've been noticing as I've been grading people's papers over the last month or so, that people who mess up the word problems, they're messing it up because they're losing track of what the variables represent in the problem. So if you're not specific with what x is equal to, if you just say x is babysitting, well, what about babysitting? A little bit more specific, all right? It's the number of hours, all right? So let x equal the number of hours babysitting. All right, and so y would then be the number of hours gardening. All right. Now, general rule of thumb has been if we're looking for cost or revenue, you know, like money that you're taking in, income, that you're just taking the unit price and multiplying it by the number of units. All right. So the number of hours she's working multiplied by the amount of money that she would make per hour. So it's something that you know intuitively, because if I tell you that you're going to make $10 an hour and that you're working for 5 hours, you're going to tell me that you made $50. It's just a matter of putting it in variable form. So we're looking at 10x plus 5y. Now, she wants to make at least $80 a week. All right, so what inequality corresponds with at least? Greater than or equal to. All right. So we have our first inequality. Our second inequality is that she's not going to work any more than 12 hours a week. So no more than 12 hours a week. Now, since I was very careful about defining my variables, I'm saying that x is number of hours babysitting, y is number of hours gardening. If I put it all together, that's the number of hours just working. All right. So put them together. I can't work any more than 12 hours a week. Can I work 12 hours a week? Yeah. So what symbol is going to be appropriate here? Less than or equal to. All right. So we have our inequalities. It's just a matter of coming up with the graphs of those inequalities. Since we're living in the first quadrant here, graphing by intercepts is the most convenient way to go. It's up to you whether or not you want to do it. But I'll tell you right now, you will run into scaling problems for some of these questions if you try to get every one of them in y equals mx plus b form. All right, so don't fall in love with that concept. You got to be flexible. All right, and so in this case, your best bet is to identify the x-intercepts and the y-intercepts for each of your equations. So x-intercept, y-intercept. Now, I'll just color code it, I guess. Here's my first equation. Make it blue. So here's equation, I'll call it equation 1. And purple for those keeping score at home. That's equation 2. All right. The x and y intercept technique is very easy because there's really not much that you need to do. All right. So if I'm trying to find the x-intercept for my first equation here, all I'm doing is I'm covering the y variable, because really you're replacing the y with 0 and simplifying. But that's going to wipe it out. So if I have 10x equals 80, what does x have to be? 8. 10 times 8 is going to be 80. So I have my x-intercept is 8. For my y-intercept for that first equation, right, I cover up the x. I have 5y equals 80. So what's y have to be? I think I heard it. Not 12. 12 will give you a 60. 16. So I have my x and y intercept for the first equation. Much easier in the second case. Cover up the y, x equals 12. Cover up the x, y equals 12. All right, so in both cases, 12. What don't you get?
like.
Yeah. I'm confused.
So cover up the x, solve for y, cover up the y, solve for x. That's really all there is to it. Yeah, because if I'm looking for an x-intercept, cover up the y, solve for x.
Oh, I get it.
Oh, see.
Yeah.
Oh.
It's very, very simple.
Oh,
Okay.
see. Oh.
You just like the.
I don't know. I think that's something else.
I need a calculator.
Yeah, sometimes you need a calculator,
I
sometimes
can't
it's not
do
easy.
simple math.
I think my brain cells.
My brain cell, my singular brain cell.
I only have one.
You don't even have to put them in y equals mx plus b because now I have intercepts. I'm just going to plot these points and connect them. All right? So in this case, I don't need a scale because my x and y values are very reasonable. My x-axis and y-axis go out to 20. So I can plot 8 units in the x direction and 16 in the y direction. Connect those with a straight line segment. Then 12 and 12, so 9, 10, 11, 12. Connect those points with a straight line segment. And so now we have our lines, but the issue is you got to be mindful, and in this case I'm okay, but you got to be mindful of the fact sometimes they're going to be dashed and sometimes they're going to be solid. In both of these cases, they're solid line segments, but we've all been in that situation, I think, where you just got through drawing out a line in 10 to find out that it was supposed to be a dashed line. And so then what? You know, you got to start over. So I got to shade this. All right, so this is where the technique might seem to fall apart. You would say, well, how do I shade it if I don't have it in y equals mx plus b form? It's actually very easy. What you're going to do is choose a coordinate, a convenient coordinate that's not on either of the two lines, and plug them into your inequalities. All right, so I'll just make a note of that. Choose an xy value, so coordinate, not on either line, and plug into both inequalities. All right, so we have one inequality, 10x plus 5y greater than 80. So 10 times my x value plus 5 times my y value is going to be greater than or equal to 80. And then x plus y was going to be less than or equal to 12. You just got to decide on a nice, convenient xy value, xy coordinate. All we're looking for is a quick true false. So when I choose these values, or the ordered pair, the xy, to plug into my inequality, it's either going to give me a true sentence or a false sentence. All right, that's going to dictate how I shade. All right, so looking at the graph, can you give me the most convenient xy coordinate that does not fall on either of those two lines? 0, 0, exactly. All right, that if you have any control over the situation, and you do, we want to choose 0, 0 if possible. All right, if 0, 0 falls on one of the two lines, then it's not possible, so you can't do it. But I'm going to pop zeros in for both x and y and see if I get a true sentence or not. All right, so 10 times 0 plus 5 times 0, what does that give me? 0. Is 0 greater than or equal to 80?
No.
No, so that's a false sentence. 0 plus 0, 0, is that less than or equal to 12?
Yeah.
So it's a true sentence. All right, so bless you. This is the part where we have to make a determination of, okay, well, what did we do this for? If it's a true sentence, you shade in the direction of that coordinate. If it's not, you shade away from that coordinate. So looking at my first line, the first one was the blue one, right? I have a choice of shading below or above. 0, 0 is right down here. I just determined that it was a false sentence. So I have to shade above my blue line, all right? Points above my blue line. For the other one, it was a true sentence. So for my purple one, I want to shade in the direction of 0, 0, because you're always, if it's a true sentence, you're going to shade in the direction of that coordinate. So I'm going to shade below the purple, but above the blue. All right? So some parts of it are a little obvious, because if I'm below the purple and above the blue, I'm definitely living in this region here. But the other piece, you would say, okay, below the purple and above the blue, is that even possible? Can I have a shaded region that is both below this purple line and above this blue line at the same time? No, because they're opposing shaded regions. So everything prior to the intersection is going to be completely irrelevant. It's only the area after the intersection that matters, because it doesn't make sense prior to that intersection. Because I can't be below the purple while also being above the blue, at least for that portion of it. But for this portion of it, I totally can. Below the purple, above the blue, that's the area in between. All right, so it does take a little bit of thinking, but you can definitely get there.
So wouldn't that be the exact same shading, like process, not process, but like answer if you were to do the y equals mx plus b way?
Right, but the problem is,
That one always works.
not, well, the numbers that you get when you use y equals mx plus b for some of these word problems are going to be so nasty that, like, counting a slope when you have something like negative 1.17, you know, it's going to be such a pain that you don't want to do it that way. So going by intercepts ends up being the better approach. What most people have kind of come to terms with is that for pretty much anything except for word problems, y equals mx plus b is the way to go. But when you're dealing with word problems, you generally want to do it by intercepts. All right. But, you know, give it a shot. Give it a shot any way you want. And then, you know, you'll come around to my way of thinking at some point. So your responsibility is pages 36 to 39. So really, your responsibility is the rest of the packet, right? Because we're taking a test on Friday. That was the last lesson. So tomorrow is all review. So you're just working through the remainder of the packet, practice, get into that review section, and really just kind of get yourself geared up to take that test. All right. So that test that test counts in the second marking period. So keep that in mind.
Oh,
All right.
it's for the
So
second mark?
yeah. So it's a good way to get started off on the right foot in the second marking period. All right. So don't blow it off figuring that your grade is pretty much set. You know, like, you know, for the first quarter. It's not going to count in your first quarter, all right?
Can I try to find my pencil case?
Yeah.
Thanks. I think it's in my ELA
The
class.
quest begins. The calculator sheet? Yeah, do you have your calculator?
Yeah.
Yeah, you might as well get it out because it's different for every calculator. I'm going to upload this. Do not put your nose on the window. Yeah, like, I can tell you in all honesty that those windows, maybe they're cleaned once a year. Yeah, it's like a haven of bacteria.